A lava lake in Hawaii's Kilauea caldera spent 10 years spilling and roiling before the volcano let out a larger belch, researchers report. Kilauea erupted dramatically in 2022. Earthquakes, ash plumes, and lava flows destroyed more than 700 homes on the Big Island of Hawaii and changed the volcano's topography. But Kilauea erupted more gently for a decade before its Big Bang. One of the salient features of this slow-moving eruption, a persistent lava lake forming within the Halema'uma'u crater at the summit of Kilauea. New research reveals how the dynamics of a lava lake, together with the deformation of the surrounding soil, encode signs of volcanic gas migration and changes in magma temperature in the volcano's shallow pipe system. This is a very popular new look at volcanic dynamics, said Leif Karlstrom, an earth scientist at the University of Oregon who led the research. One could stand near the edge of a lava lake and visit the lava flows that erupt. But beneath the surface, there was much more going on. The Kilauea lava lake is fed by a magma chamber underground, which is connected to the surface by a passage. Because lava cools and hardens fairly quickly, maintaining a consistent lava lake requires an extraordinary balance, a steady flow of new lava from the depths, with enough lava remaining to prevent too much pressure from building up. To learn more about the deeper dynamics of the volcano, the researchers analyzed data collected by the Hawaii Volcano Observatory from 2008 to 2022. A series of sensors placed around the volcano recorded vibrations and other disturbances. Once something physically disturbs a magma chamber or lava lake, it spills over, and we can measure it with a seismometer, said Josh Crozier, a former doctoral student now at the California Volcano Observatory at the U.S. Geological Survey. During this decade-long eruption, we detected tens of thousands of such events. We combined this data with a physics-based model of the process that created this signal, says Crozier. Just as the sound made by a fork tapping a drinking glass changes based on the amount of liquid in the glass, or the sound of a drum changing based on its shape, the seismic signals observed around the peak of Kilauea encode the resonance of magma spilling in and out of the shallow magma chamber. This characteristic of resonance, unlike simpler musical instruments, is determined both by the shape and properties of the magma, such as temperature and gas content. Carefully checking for resonant signals throughout the eruption. Researchers can deduce what's going on inside a volcano without directly investigating the hazardous and extreme environment. We can actually see gas formation over time and temperature changes without direct measurements, says Crozier. A simple model for an effusive volcanic eruption like at Kilauea says that magma is pushed from the depths and gushes out of the volcano, like toothpaste squeezed out of a tube. But in the case of the 2022 Kilauea eruption, we see no sign that there was a large magma flow leading up to the eruption, said Crozier. In contrast, the new analysis supports the idea that shallow processes associated with draining the summit magma chamber into the volcano's eastern rift zone helped shape the major eruption. It's too soon to use that information to predict future eruptive behavior, Karlstrom stressed. But ultimately it could help scientists make more precise interpretations of the volcano's seismic signals. That's the next step, identifying the implications of the variation we found for the dynamics and human hazards of volcanoes, he said.